Hello world, in this video I will talk about Chao Tree. It is a kind of segment tree, so I'm assuming that you have some knowledge about segment trees to proceed further. What Chao Tree is and what it does, we will understand through a problem statement. So let's see what the problem statement is. The problem is taken from AdCoder's educational DP contest. There are 26 problems here from A to Z, and some problems are really nice. You can check it out. Link is in the video description below. What we are discussing is problem Z, frog 3. So I will recommend you to pause the video, go to that link, read the problem statement, and then come back. But anyway, I will describe the problem briefly, what it is actually. So there are n stones numbered from 1 to n. The frog is initially at first stone and it has to reach the nth stone in such a way that the total cost incurred is minimized. So suppose a frog is at ith stone, it can jump to any other stone on its right. So one way to go from 1 to n is directly jumping from 1 to n. Other way could be, and the cost of this path will be hn minus h1 squared plus c. Or it can go from here to here. Say this is stone 3. So the cost will be h3 minus h1 whole squared plus c, and then h3 to hn. Or maybe so the total cost from 1 to n by following this path will be hn minus h3 whole squared plus c. So the sum of these two. Maybe this one is smaller than this one. So what we really have to do is to minimize this total cost. So, and we have to return that minimum value. So yeah, this is what the problem statement is. Here it is given that h1 is smaller than h2 is smaller than hn. That means stones are in increasing order, but Chao Tree doesn't care about this. Our solution will even work if this condition is not true. Say h1 is greater than h2 and then smaller than h3, means any random order, Chao Tree will still work. So this I don't think this problem statement is intended to be solved by Chao Tree. We can utilize this using convex hull trick, because convex hull tree will utilize this condition very efficiently. So yeah, we will I think I will discuss about convex hull trick in the next video. So stay tuned for that. Now let's come back to the Chao tree. First, we will understand what should be the dynamic programming solution to this one. Let's define dpi to be the minimum cost occurred to reach stone I. So what would be dpi? Suppose we have already computed dpj for all j which is smaller than I. So dpi will be c plus minimum such that j is smaller than I hi minus hj squared. If we are jumping from jth stone to ith stone, plus the cost to reach the jth stone. The most obvious way to solve this problem is n squared, right? For a given I, suppose you have already calculated all previous dp values from I equal 1 to I minus 1. Then For a given I, we will run a loop again from 1 to I minus 1, and we check which value will going to give the minimum of this. That will be our answer, right? Yes. So I'm expanding this equation, hi squared plus hj squared minus 2hi hj, and I am taking this hi squared out of this min bracket, because since hi is dependent on I, it will not going to depend on this j. Whatever can be the j, this hi would be same for a given I. So I'm writing it in this way: c plus hi squared plus minimum of j such that j is smaller than I minus 2 into hi into hj plus hj squared plus dpj. Now we can see if we replace hi by a parameter, that is x, we can see this is a equation of a straight line. So let's just say, suppose we have all those straight line equations like this. Suppose we have y equals minus 2 h1x plus h1 squared plus dp1, and we also have another line equation, y equals minus 2 h2x plus h2 squared plus dp2. Say we have till n minus 1, y equals minus 2 hi minus 1, hi minus 1 x plus hi minus 1 squared plus dp3. See, all these equations are straight line because h1 is constant, which is already given in the problem, and h1 squared plus dp1 is constant, because for a given h1, to reach a given stone, there should be only one minimum cost, right? If there are two different, I meant to say dpi will have a constant value. So this is also constant, this is also constant. So we can write all those values in this way. Suppose we have calculated dp1 to dpi minus 1. I'm sorry, here it is not dp3, it is dpi minus 1. So now it is very easy to calculate this value. We will just put in place of x this hi, and whichever line will give us the minimum value, that line will be our answer, right? So what I'm trying to say, let me describe it in graphical order using some coordinate. Let's just say we have this is our coordinate. Now I'll use black. So let's just say first we have to calculate dp1. So dp1 will be 1, right? I mean dp1 is 0, because to reach first stone we do not have to incur any cost. To calculate dp2, and dp1 is 0, now we have to insert this line equation. We have calculated dp1, now we have to insert this line equation here. So we know minus 2, we know h1, so this is the slope minus 2 h1, and we also know that h1 squared plus dp1. So we can write a line equation here. So So this is the line equation. Now now we have to calculate dp2. For dp2 we know c plus, remember we are calculating dp2 with this equation. We know c, we know h2, and we know c, we know h2, so c plus h2 squared, plus minimum of j such that j is smaller than 2. So there is only one line. So suppose this point is our h2. Since there is one line, there is no point of saying which line will give the minimum value at this point h2. So since there is only one, so we have calculated this line, whatever this line, let's say this line is L1, whatever it will going to give us at h2 value, and we will return it here. Let's say it is some constant, say C2. So we have calculated dp2. Let's just say this, at this point this line will give us, say, value C2. So dp2 is nothing but this. Now we have to insert this line, this line into this set of lines. So let's just say if we insert, we know h2 and these all are constant. So let's just say we insert this line. Say this line becomes something like this one. I'm just taking an example. So this is line L2. Now we have to calculate, we have inserted this line, second line. Now we have to calculate dp3. For dp3 we know c plus h3 squared plus the minimum of these two lines, means at point h3, which of this two line will going to give us the minimum? Surely I can say, safely assume that here in this case second line will going to give us the minimum value. And if by any chance h3 is not here, say h3 is somewhere here, then the first line will going to give us the minimum value. It doesn't matter, but what we have to do is that using both these two lines, we can compute which line will going to give us the minimum answer. So say in this case, the line 2 is going to give us the minimum value at h3, say somewhere here. Okay, I have to extrapolate it. So this is, let's say this is C3. So we have calculated dp3. This point is called, let's say, C3. Now we have to insert this line. Similarly, if we have to insert dp3, we will just calculate slope minus 2h3. And then we will calculate that intercept, that is h3 square plus dp3, since we have already calculated dp3. So again, we have inserted a new line. Let's say dp3 is something like this. Let's say this is L3, this new line. Now, so on, we calculate dp4 in similar way. Suppose h4 is somewhere here, h4. In this case, L2 will going to give us the smaller answer, whatever the value is. So I think you have got the idea what I'm trying to do. The problem with this approach is, by doing it in the most natural way, it is still n squared. For every point, we are again checking in all those lines and seeing which line will going to give us the minimum value at a given point, h4 or something, right? So this is where Chao Tree will come into picture. But before digging into that, what kind of operations are we doing? the first operation is to insert a new line in a set of lines. So the first operation is to insert a new line. And the second operation is to find minimum at some value x equals x naught. Find which line gives the minimum at x equals, say here at x, for h3 we are demanding, at this point we are demanding. So at any point, suppose we have a point x naught, we have to find what is the minimum value, which line will going to give us the minimum value, and then return that minimum value, right? If we can do these things efficiently, then we are done, right? So that is where this Lee-Chao tree will come into picture, as we are going to see. Lee-Chao tree. As I said that this tree is actually like a segment tree. A segment tree has a node. A node has some number, let's say it's the first node. And it signifies a range from L to R. And if it is a minimum segment tree, so whatever be the minimum between L and R, it will, so a node also has a value. In Lee-Chao tree, that value is called, not a single integer, it is a line. Say it is a line y equals ax plus b. So we store two values, this slope and this intercept, a and b. So inside a node there should be a line. Let's call this line L1 or something. For node 1 it is L1 for node. So this is how a single node of Lee-Chao tree works. So it has a dominating line. I will talk about what this dominating line means. So initially, for this problem specific, this L should, and what should be the initial values of L and R? Since H1, H2, all are ranges from 1 to 10 to the power 6. So this L should be 1 initially, and R should be 10 to the power 6. I have represented in my solution, I will show you in a moment. I have represented in this way, L to R. R is not inclusive. So it is from 1 to, in my representation, it is from 1 to 10 to the power 6 plus 1, because we have to include till 10 to the power 6. So this is it. So let's just go to the concept of dominating line. So what is a dominating line? Initially we will assign all node values to be line y equals infinity. Can be written as y equals 0x plus infinity. So a line which is like initially, which is like at infinity, whatever be the value of x. So why are we initialized it in this way? And infinity is a very large number. I had taken in my solution, link is in the video description below. I had taken infinity to be 10 to the power 17 because I'm sure that 10 to the power 17 will never go, any DP value will not going to reach 10 to the power 17. So it is a safe bet. And why I'm taking it? Because if we are inserting any new line, we are sure that for a value, this 1 to 10 to the power 6, this new line will be somewhat like this. So it will always going to replace the initial line. So that is why we have taken 0x plus infinity, because any line can replace this line, because comparing this and this, the minimum value we will going to get is a line which is not at infinity, like this one. So I hope this makes sense, and it will if you just wait for a moment. So so this is how I initialized it. Let's say we have to insert a line. Let's just say first, let's just say we have a node, and this node has a dominating line like so. Initial in this node, this is the dominating line. So let's say this node represents from L to R exclusive. Like this node is representing from L to R, like so. And initially, this line is inside this node. And let's just say M that is mid is L plus R by 2. So mid is somewhere here. Let's draw a line for mid 2. So this is mid, and initially this line, let's say it is L1. For this range, this line is the dominating line, and we have to insert another line here. So what will going to happen? Let's just say another line is like somewhere, something like this. For example, let's say another line L2 is like this. So what is dominating line? The dominating line is a line which covers, which has its significance in both of its left part and its right part. Let's just say which line has more significant on the left side. As you can see, L2 is minimum on the till this value. Whatever be that intersection point, till this value L2 is minimum, and after that L1 has more significance, means the previous line. So L1 has its significance both on the left side and the right side. So we will not update our current node. Let's say we are at node V. V has a range. L to R, and V has a value. The value is line L1. So still we can see L1 is more significant in this range, in this node V. So we will not going to update it, but instead, as you can see, our query will going to go insert this line L2 on the left side. Why? Because in this line, this is not significant, but maybe in future on the left side, this L2 has more significant, and this L2 will never going to have significance on the right side, because right side it is strictly greater than L1. So it can only play role on the left side. So we will for point V, we will going to reach the node, let's say 2 into V, because we are going to left side, and 2 into V plus 1 if we go to the right side. So we reach the node number 2 into V. And let's just say now we have this L to M. And let's say this midpoint is M1. So we have reached 2 into V. And now if you see, if you are going to see that L1 has less significance, because in this position, in this range L to M, so for 2 into V, the range is L to M. Or initially, let's say the dominating line is L1, because that is how we initialized. But now we see that this line L2 has more significance here, because L2 is also on the left and also on the right. Yeah, I think you got it. So we will replace its previous L1 to L2. The new value of the node is L2, but again, we will again going to go to the right, because maybe we have replaced the parent node to L2, but this L1 can have more significance on the right, because as you can see after this point, so we will again go from 2 into V, so we will again go to the right of this node. So as you can see, we are at V, we go to the left of whatever 2 into V, and then this time we will go into the right because the intersection point is in the right, and this time we also swap this value L2 with L1, because now the dominating line is L2. And now our query will become replace L1 with the previous dominating line there, if it is possible. I hope you have got it what it is. So here we will go 4 into V, I think it is 4 into V plus 1, because we are, this side should be 4 into V, this side should be 4 into V plus 1. If the first node is, if node 1 is 1. Yeah. So now we will go here and we will see the midpoint. The dominating node is L2, not L1. So if it is previously L1, we'll replace it with L2, because L2 is both on the left and on the right. One thing to note is that we have swapped L1 with L2. Now if we go to here, our new query will be to insert line L1, not L2. Why? Because now we have said that the previous node is more dominating. In this case, since parent is L2, so our new query should give justice to L1, because L1 is more dominating now. So if we go from this node to this node, our query will be of insert line L1, if it is possible to insert, not L2. And as soon as we hit, say, a given LR, where R equals L minus 1, then we are done, right? Because we have reached the last node, so we will going to return from it. So this is how this is how Chao tree works. For query, it is simple. It is super simple. For query, suppose we have a query X. Initially, we are from, say, 1 to 10 to the power 6. So we check. So we check what is the value of this X in whatever the line that is dominating here. Say it is L1. What is the value of X here? And if X is smaller than mid, we will go to the left. If X is greater than equal to the mid, we will go to the right. And we will continue till we reach range X plus 1 exclusive. So we have reached the X point. So any line which gives the minimum value in this path, that would be our answer. So it is simple. Now let's see the code, how I code it, so that you will going to have a more better understanding of what I meant to say. This is the code. Link is in the video description below if you want to check it out. So we have initialized this n value as 10 to the power 6 plus 1. Why? Because hi cannot be greater than 10 to the power 6. We have initialized infinity with 10 to the power 17, which I have already discussed why. So from here we are making that Chao tree. So the node size should be 4 into n, because n is the range, 10 to the power 6. So the number of nodes is, in worst case, can be 4 times this size. And we are initializing each node with 0. The first part is 0 and infinity. It means for y equals ax plus b, the 0 part is a That means the first part is the slope and the second part is the intercept. So we are initializing with lines y equals infinity. I've already discussed why we are initializing it with this line. So this f is doing nothing. It takes a line y equals ax plus b. So, and at any point x equals x, what is the value of this line? So it is returning the value. So it is slope times x, ax plus b. This line 1 is b. Very simple. Now for the insertion part. We are inserting a new line which is called line. Strange. I haven't changed this name. I didn't see any other name, so I have just go with the line. I can call it new line or something. And we have a low value which is initially initialized with 1 because our range, if you remember, it is from 1 to 10 to the power 6, and high value is n. N is not exclusive because I've already told I'm using low inclusive, high exclusive. That means if low is 1, high is n, then we are only considering from 1 to n minus 1, and n minus 1, as you can already see, is 10 to the power 6, which served our purpose because hi cannot exceed 10 to the power 6. This I is 1, as we have already discussed. Why? Not why, we initial node is 1. So m is low plus high by 2. We are getting the mid value. This left is checking whether our new line, which is to be inserted at point low, is smaller than our previous line tree I at the same point low. And what mid value is checking? It is checking whether our new line at point mid, m is mid, is smaller than the previous line tree I at mid. So let's first understand what we are going to do with this mid and left. Let's just say this is our previous dominating line at node I, tree I, which ranges from L to R exclusive. Let's just say a new line came, something like this. So this new line come. So how do we going to find which line is dominating? A simple way to see which line will going to give us smaller value at point mid. Why? And this is what exactly our mid variable is doing in our code. So if mid is true, that means our new line will going to dominate this. So this is a simple way to find which one will going to dominate. And there is another variable left. And similarly, if mid is false, that means our previous line is dominating. We don't need to swap these two. There is another variable left. What it is doing, that mid only can tell which line will going to dominate, but mid will never going to tell if where the intersection is happening. It is happening on the left side or it is happening on the right side. To check this, we will also compare those tree values at point L. If at point L our new line previous value is smaller than tree I, and at point mid they interchange, means the line value is higher than tree I, or those two are not equal at these two places, that means we have an intersection at this point. Suppose tree I is greater here than the new line, and tree I is also greater at point M2, at point M also. So what we can say that they didn't intersect here. They definitely have to intersect somewhere here on the right. So we will go to the right, and if the mid value is equal to the left value, then we will going to go to the right. And if these two changes, that means intersection happens on the left side, so we are going to go left. So let's jump back to the code. Now that we have understood what mid and left is serving the purpose, it is simple. If mid is true, we are swapping tree I with line, as I have already discussed. And if high minus low is 1, that means we have only one node. We are returning 1. We are returning, sorry. Else if left is not equal to mid. So if left is not equal to mid, that means our intersection happens on the left side. So we are inserting line, low, mid, and 2 into I. Else we are inserting line at mid, high, and 2 into I plus 1. This is super simple, right? Now query is even more simpler. We have to query from for every node in the path of x. So we are given a value x. Low is 1, high is n, and I is 1 because the first node is 1. So m is low plus high by 2. And we are checking what is the current value at this point, at our current dominating node at tree I of our required query x. So if high minus low is equal to 1, that means we have reached, that means our low is x. So that means we are returning current answer. Else if x is smaller than m, we are going on the left side. So the answer can be current node or its previous one or its below one on that part x. So that is why it is basically traveling for, as I've already explained how we query, we travel to each of these node and node till the last, and whichever node gives the minimum, that should be our answer. It is obvious, right? So it is doing exactly the same thing. It is if x is smaller than m, then we have to go left. If x is greater than m, then we have to go right. That's simple. And what we are doing is nothing but we have initialized dp with size n and calculate. We are taking input hi, and then these all are self-explanatory. I have already explained it in more detail. So thank you for watching this video. I hope you have understand, and if you don't know, I hope you have learned something. And thanks for watching. I have already told that before. Okay, bye.